and welcome Mindsetters to this session of Learn Extra Live for grade 10's maths literacy. I'm Ty and I'm here with Haley. She's
Hi,
going to be taking us
Ty.
through today's session. What
Hi,
are we doing
Greg
today,
10.
Haley?
Today we're going to do some revision. We're just going to
Alright.
go through like a little bit of everything they've done.
Alright.
And hopefully, I can't believe we're actually at revision time of the year.
It's that time.
Scary.
It's that time. Exams
It's
are coming
scary,
up.
like the time's just flying like this.
Exactly.
But yeah, revision today. It's going to be fun.
Alright. Okay, so while you make your way across
we'll
the
do
board,
that.
Mindsetters, you know the drill by now. You need to get on the page. You know the link, www.facebook.com/learn extra. Talk to me. Let me know what you guys are thinking. If you're lost anywhere, if you need help, post. Because as I keep saying, we can't read your mind through the screen. And there's no such thing as a dumb question. Because that question might be another question someone else might have. So, post. And don't forget to help each other out. It's so important, so important. But on that note, this is where I hand over to Haley, who's going to take you the show. Haley, take it away.
Thanks, Ty. Hi, guys. Before we start the show, you know what I always do at the beginning of my show. I like to look at the numbers. So let's see. What are our numbers, Ty? Last week, we were on 17,410. What are my numbers today?
We're on 17,931.
17,931. That's great. I was just discussing with Ty before we started the show, and I said, I hope that we get to 20,000 soon. He says, no, we'll get there in a month. And I'm hoping that I'm also on the show when we get there because I missed the 10,000. But anyway, guys, we are still going to use these numbers, so don't worry about it. Right. Today we're going to be doing some revision. So the best thing is to just jump in and let's go do some questions. So we're going to start off. Right. We're going to start off with some calculator skills. And we're going to be looking at calculating each of the following correct to one decimal place where necessary. That's always important for us to actually read the question carefully. So we know we need one decimal place. I like to highlight it just so that I remember. But remember, I always go back and I reread the question, so we'll check it out. So our first answer is 42,35 divided by 3 quarters, divided by 3 over 4. Now, so what we actually have here is 42,35, and I'm going to rewrite it as divided by 3 over 4. And then when we divide by a fraction, we can multiply it. So let's get our eraser out, and let's erase that. And we're going to multiply it. And we're going to flip that around. So we're going to multiply not by that, but by 4 over 3. So I'm going to get my calculator out. And now, I'm not sure how many of you out there, and in actual fact, it might be an interesting statistic. Maybe we can ask Ty to actually post it. I don't know how many of you grade 10s are actually using scientific calculators. But remember, the syllabus only says you need that 4-function calculator. So I'm going to try not use the scientific part, like I won't use the fraction. So I'm going to do 42.35, and I'm going to times it by 4, and I'm going to get an answer, and I'm going to divide it by 3 and get an answer, and that is 56,4647. Remember, it said one decimal place. So 56,5 is our answer. So let's write that in there, 56,5. Right, and moving on to the next question. Right, 5 plus 6 times 4 divided by 2 minus 6. And in this case, we really have to remember our BODMAS. So I'm going to write our BODMAS. Let's change colors, and I'm going to write my BODMAS. If you are using a scientific calculator, then you can just type it exactly the way you see it. But because we're not going to use the scientific part of the calculator, we're going to do this ourselves. So we're going to do the brackets first. So brackets is 2 minus 6 becomes minus 4. Okay. Then we're going to do division multiplication. We can do those at the same time. So I'm going to actually multiply first. 6 times 4 is 24. I probably should be writing this underneath. Let's write it underneath. 24, and that's minus 4. So let's get our let's erase those numbers there, just to make it a little bit neater so we don't get mixed up with 1. And back to our calculator. Right, and now we're going to divide. So 24 divided by negative becomes a negative 6. And then we've got 5 plus that, or 5 plus minus, so 5 minus, and we end up with a minus 1. So I hope that you all followed that, and the operations are important. So scientific calculator, we could have just typed it straight in. We would have got the same answer, but remember, BODMAS. And the next one is 2/5 plus 3/8 times by 5/17. So the first thing we need to do is we're going to multiply. Now, when we multiply fractions, we multiply the top, we can multiply the bottom. So 3 times 5 is 15. And 8 times 17, I'm going to need a calculator for this. There's a calculator out. Right, so I've got 8 times 17 is 136. So I've got over 136. And to this I need to add my 2/5. Now I can't add them if they are different denominators. So what I need to do is I need to get a common denominator. Now the easiest way to do this, and because you've got calculators and you can simplify at the end, is let's multiply these. 5 and 136. So I've got my 136, I'm going to say times by 5, and I'm going to use 680. So I'm going to make this 680, and I want to make that 680. So what did I do here? Here I times by 136 over 136. And here I times by 5/5. So 2 times by 136, let's get our calculator out. 2 times by 136 gives me 272. And 15 times 5, calculator out again, 15 times 5 is 75. 75. Now I can add those two up and quite clearly see that it is, let's do it on the calculator, 75 plus 272, and we see that that's 347. So 347 over 680. And that is in its simplest form. So we're going to leave it like that. We're going to leave it as a fraction. So on our calculator, we could have used the fraction buttons, but like I said, I don't want you to use the fraction buttons if you, no, let me rephrase. If you're using a scientific calculator, then use your fraction button. But if you're not using a scientific calculator, then you're going to write it, you're going to do the calculation exactly the way I did. I hope that makes sense. Let's move on to the next question. Right, conversions. I seem to have lost my pen. So, conversions. We need to convert from one unit to another. So the first is meters to centimeters. Now, I don't know if you remember way back when I did conversions with you, I kind of like made this little table. And whenever I do conversions, I put this table into my paper. So let's do the conversions. And what did I say to you? I said to you, and I don't have a ruler with me, in your pencil case, I hope you've got a ruler. And that ruler is your little cheat, your legal cheat. Because from the ruler, we can see that 10 millimeters is equal to 1 centimeter. And then we need to now just think, how big is a meter? And a meter is about, like if I stretch my arms, and I don't know if I'm in camera or out, if I stretch my arms, that's about a meter, or a big, if you take a big step forward. And quite clearly that's more than 10. So it must be 100 centimeters is 1 meter. And finally, a kilometer, I usually think about distance when I'm traveling on the road and I see the sign and it says that it's 1 kilometer away. I can see that that's more than 100, so it must be 1,000. So we've got 1,000 meters is 1 kilometer. The other way you could remember it is just 10, 100,000, 111. Hey, when we go from a small number to a big number, we need to multiply. And from a big number to a small number, we need to divide. And once we've got that, then it's easy for us to do all the conversions. So let's read the question now. We're converting 233 meters to centimeters. Sorry, we're converting 2,33 meters to centimeters. So first of all, I find that in my table. And I need to find them on either side of the table. So I've got centimeters to meters. Right, and I'm converting from meters to centimeters, which means I need to multiply. As I'm going from this side to that side, I multiply. What am I multiplying by? I'm going to multiply, and I'm multiplying by the number that is there. So I'm multiplying by 100. And that becomes 233 centimeters. Right, let's do this again. Now let's do it in our next question. Let's change colors. Right, so we're going from 0.45 meters to millimeters. So I'm going to delete my yellow that I had, because now I want to go, right, let's go back to this turquoise. Right, I'm going from meters to millimeters. Meters on this side to millimeters on that side. So I'm actually jumping kind of 2 steps. So I'm going to go 1 step and then another step. So I'm converting from meters to millimeters. Again, I'm going to be multiplying. So we're going to be multiplying. Let's write in our number here. And what am I multiplying by? In my first step, I multiplied by 100. That's going to give me centimeters. Then I go convert from centimeters to millimeters, which is another 10. So I can combine these and say, well, okay, there's actually 3 zeros. So I'm going to multiply by 3 zeros. And if you'd like to use your calculator to check everything, you don't have to do anything in your head. You've got a calculator with you in your exams. So use the calculator. 0.45 times by 1,000, and we get an answer of 450. So that's 450 millimeters. Don't forget your units. Really, really important that you have your units. Right, and 255 milliliters to liters. Right, what do I know about milliliters? Now, I always like to think about my bottle of water that I carry. And I carry a 750 ml bottle of water. And I know that it's just less than a liter. So I know 1 liter is equal to 1,000 milliliters. Now I'm converting from milliliters to liters, which means I'm going from my big number to my small number. So I'm going to divide. So I'm going to take my 255 and divide it by 1,000. And you can use your calculator again. And it's 0.255 liters. Now in this case, I haven't rounded off. I've left it the same with 3 decimal places. And I know I'm always on at you about rounding off to 2 decimal places. But in this particular example, I would leave the answer exactly the same, because they're asking you to convert, so we want it to be exact. But having said that, your teacher can't mark you wrong if you round this off to 0.26 liters. So that's, well, my theory. I'm going to leave it the same. Right. A cube has a volume of 1.25 meters cubed. What is the volume of the cube in centimeters cubed? Now, when we compare a squared or cubed units, well, in this case we're converting cubed units. First of all, let's see how many centimeters in a meter. Let's go back to our thing, and we see that we've got 100 centimeters in a meter. So we know there's 100. Lost my pen. We've got 100 centimeters is equal to 1 meter. We're going from meters to centimeters, which means that we are going from a small number to a big number. We're going to be timesing it. And it is cubed. So we actually have to do this either 3 times, or we can cube it. So let's do this calculation slowly. So 1.25, and we're going to times it by 100. That's 1 dimension. We need to times by 100 for the second dimension, and we need to times by 100 for the third dimension. So because it's cubed, we're going to be converting it 3 times. And the reason we do this, I hope this makes sense, but let me show you with squared. Let's just change our pen. If we look at our square, which is 1 meter by 1 meter, and area of the square is 1 meter squared, length times breadth. And what we have is 1 meter we know is 100 centimeters. And this is 100 centimeters. So my area is actually 100 times 100. Or you can write it as 100 squared. So that is why we do it with cubed. So I'm going to go back to my answer here. And let's get our calculator out. And we can say 1,25 times by 100 cubed will give us one answer. Okay. Alternatively, if you don't have that scientific calculator, let's go back to the question again. 1,25 times by 100 times 100 and times 100. And we're going to get the same answer. So it's 1,200,000, let's get that, 1,250,000. And don't forget your units. Now we've got centimeters cubed. So that should take us through conversions. So I think let's see what our next question is. How's our time going there, Ty?
Well, I'm thinking we could jump into a quick ad break before we get into the rest of this question. What do you think?
So, okay, maybe we should take a break now, but post that question about, I'm interested to know if they're using scientific calculators or not. I'd like to see what kind of response we got. And yeah, let's take a quick break, give them a little bit of a stretch, and then we can carry on with this.
All right, no problem. So mindsetters, you heard the lady. Make sure you get on the page and let me know what you guys are thinking. How many of you actually use scientific calculators? Just post it up on the page and let us know. But on that note, doesn't mean you disappear now. You come back after this break. And welcome back, mindsetters. Yes, you're back, you're ready, you've got your pens, pads out, and you're making notes, because you always need to make notes, because notes are very important, especially for exams. When you're prepping and you don't have notes, you're basically shooting yourself in the foot. But anyway, you're here, you're ready, you're making notes, which is a good thing. But on that note, this is where I'm going to hand straight over to Haley, who's going to continue the show. Haley, take it away.
Thanks, Ty. Okay, guys, welcome back. So we're carrying on with measurements. I've got another question for you. So this particular question says, find the surface area. Let's get a highlighter. Right, find the surface area of the cylinder, which has a diameter of 65 millimeters and a height of 178 millimeters. Give your answer in centimeters squared and round off to 2 decimal places. And then the following formula, they've given us the formula for surface area, and they've told us that pi is 3,14. Now, what I like to do is I always like to draw the diagram. So I'm going to start off the question by actually drawing my cylinder. Because if I've got a drawing, I always find it a whole lot easier to actually answer the question. Now, what do I know? I know that my diameter is 65 millimeters, so we can fill that in, and that's 65. And I know that my height is 178 millimeters, and these are millimeters. Now, I also know something really important. They've asked me to give the answer in centimeters squared. Now, remember how we struggled just now with converting the volume from cubed, because it was a cubed area. It is actually easier to convert first. So what I always like to do is I always like to convert first. Because if I'm converting first, then in actual fact it is a whole lot easier. I'm just converting in one dimension. So I'm going to convert the 65 and the 178. So my 65 millimeters, and I'm converting that to centimeters. And if you remember my diagram, there were 10 millimeters in a centimeter, and I'm going to be dividing by 10. So I'm going to get, let's see if we can move this over a little bit. Can't move the whole thing. Okay, we'll write it in. 6,5 centimeters. So that's 6,5. And then 178 millimeters. Again, we're going to divide by 10, and we get 17,8 centimeters. And now it's actually easier for me to answer the question. But whenever I've got a circle, sorry, that's not centimeters, that's millimeters. Whenever I've got a circle, the other thing I always like to do is actually calculate the radius. So I'm going to write my radius in, and my radius is my diameter divided by 2. So what is my diameter? My diameter was 6,5. I'm going to divide that by 2, and I'll use my calculator for that just to check. So I've got 6,5 divided by 2, and I get an answer of 3,25. So 3,25. Right, and that is my radius, and those are centimeters. Then I'm going to use my formula. So let's get our formula. Our formula was 2 pi r squared plus 2 pi rh. So I'm going to write out my formula. It was 2 pi r squared plus 2 pi rh. And I don't know, I'm in the habit of writing everything out, and I like to follow a train of thought. It kind of makes it very logical, and it's harder to make mistakes, and it's a good practice for you to get into. So we've got 2 times my pi, which is 3,14, times my radius, which I've calculated already, squared. Now, if you don't have the squared button, it means that 3.25 times 3.25. So you don't have to, let's write it again. 2 times 3,14 times 3,25 times 3,25. We could have done it that way. Okay? Plus, I've got 2 times my pi times my radius, which was 3,25, times my height, which was 17,8. Now, on my calculator, in this case, I'm just going to type it straight into the calculator, and I'm going to get, let's just do that. I'm going to get the answer. So, depending on what calculator you use, I'm going to use the square button. 2 times by 3,14 times my radius squared plus 2 times by 3,14 times my radius times my height, and check as you're typing on your calculator. It's really, really important. And I get my answer of 429,63. So this is 429,63. Double check that. 429,63. And I want to go back and double check the question. They said round off. What did they say? They said round off to 2 decimal places. So I go back to my answer and I check my answer is rounded off correctly. But what have I forgotten to do? The most important thing I have forgotten my units. And it's a surface area, so it is a square unit. So it's centimeters squared. I've got the answer in the units they're asking for, so I didn't have to convert, which is perfect. A lot easier to do it first. Okay, let's move on to the next question. Right, now we've got measurements and plans. So Mr. Harris wants to extend his driveway to the sides to create some new parking areas. He is going to remove the grass that is already there and put down stones over it. So we're going to look at his diagram. He's got grass here, and we've got some measurements. So it's 6.2 meters down, 6.4 meters across. He's got some existing driveway here, and then he's got a triangle piece of grass on the end. So that's what he's changing. He wants to remove all the grass. They give us formulas. The area of a rectangle is length times breadth. The area of a triangle is half the base times the height. And Pythagoras is a squared equals b squared plus c squared. So we're going to go through these one at a time. Let's see what the questions say. First, he has to remove the grass and replant it in other areas of his yard. Calculate the total area of the grass that will be removed from both areas. You may choose to use some of the formulas above for this question. You don't have to learn any of your formulas. They're going to be giving you the formulas. And they will probably give you the formulas within the question, which really makes it a whole lot easier. So we need, and this is where I also like to do drawings, we need the total area. So our total area is basically a rectangle plus a triangle. That's what I'm looking for. So I'm going to work out the area of each one separately, and then we'll work out the total by adding them. So my area of a triangle is length times breadth. My area of the triangle, in fact, let's do one at a time. So my length in this case was, let's make that a length and that a breadth. So 6.4 times 6.2. So with 6.4 times 6.2. And you'll notice here, like you should have noticed earlier when I taught this to you earlier in the year, I don't put my units in until the very end. I find that they're sometimes confused. So I leave it exactly like this. I'm going to get my calculator out, and I'm going to say 6.4 times 6.2 and get an answer of 39.68. And what's important though here is don't round off until the very last step. And our last step will be when we add the two areas. So our formula, let's go back to the second part. Right, let's change our colors. Formula for that is half times the base times the height. So I'm going to type it in as half times, right, let's look for, what have we got? We've got our base. So there's the base. And our height is clearly the same as that height there. So this must be 6.2, and that's my height. So if you need to turn your page around, or kind of like turn the triangle around, because I know that somehow a triangle that looks like that is easier for us to work with. So just manipulate the page so it looks like one you used to. But there's my base and there's my height. So let's do that in the calculator. So it was 3 times by 6.2. And this is something that has fascinated me in all the years that I've been teaching. Whenever my kids see this half times 3, then they immediately go, oh, well, half of 3 is 1.5. And they go 1.5 times 6.2. But in actual fact, we've got calculators, and our calculators can do this for us. So a half is 0.5 times 3 times 6.2. And our answer to that is 9.3. So we've got 9.3. And what were we doing here? We were adding these two. So let's move this down a little bit, because that doesn't look like an add anymore. No, let's delete that. And let's add them. And now that we've got our total, then use our calculator again. I've got my 9.3, so I'm going to add my 39.68. And I get an answer of 48.98. 48.98. And what are we dealing with now? Now we need units. These are meters squared. Have we answered the question? It said, calculate the total area of the grass that to be removed from both areas, and we have done that. So we've got the total area that he needs to is 48.98 meters squared. In this case, we can't round up because he doesn't have 50 meters squared. He really only has 48.98 meters squared. We can't even make it 49 meters. We're going to have to leave it exactly the way it is. Let's move on to the next part of this question. Right. To keep the stones in position, he is going to lay some bricks along the edges marked in bold. So which of those? Let's actually try and color them. So we're going to, there's our bold, and we've got, there's a bold there, and there's bold there. Whoops. Right, so that's where we need to put bricks. So, okay, I think I've got that all colored in. Right. The other edges are next to the house or bordering on the existing driveway, so he doesn't need to worry about them. Calculate the total length of all the edges that he is going to have to lay bricks on. So what are we dealing with now? We're dealing with perimeter. So we need to calculate that edge. Well, clearly that's 6.2. We've already got that. So we've got the 1. That edge there has to be equal to that edge there. So that is 6.4. So the one that we really don't have is this edge here. And what do we know? We know this is 6.2. So this is where we're going to have to use our Pythagoras. We're going to have to calculate, that is our hypotenuse of a triangle. So what I like to do here is redraw the triangle into one that I recognize, what I'm used to. What I know, my base was 3 and my height was 6.2. Sorry, the height was 6.2. What I'm looking for is that there. Now, the formula they gave us was they said that a squared equals to, and they gave us a squared equals b squared plus c squared. Right. Clearly, this is a. There's b, and there's c. So we've got a squared is equal to b squared. We're going to substitute 3 squared plus 6.2 squared. And I'm going to do that on my calculator. I'm going to get a squared equals, let's get our calculator out. Right, it was 3 squared plus 6.2 squared. And we get an answer of 47.44. But I want A on its own, so I'm going to have to square root it. So on my calculator, I can square root the answer, and I get 6,887. So I'm going to make it 6,89. So that is 6,89. Right, let's write that in. So that's 6,89. And now I need to add these all up. In fact, I'm going to leave it as 2 decimal places. But if your text is working with 1 decimal place, you probably could work with 1 decimal place. So now we just need to add these all up. So it's 6.4 plus 6.2. So we need to take that. Let's get a different color so we know what to do. Plus 6.4 plus 6.2. That's going to give us our total. So on our calculator, right, we've got 6,89 plus 6.4 plus 6.2. And our answer to that is 19.49 meters. So that is the bricks. Okay. Each brick is 24 centimeters long. How many bricks is he going to need if he wants to put them along the marked edges? Ignore the thickness of the cement between the bricks. That basically means we're putting one brick, the next, and the next, and the next. So we could do this a couple of ways. Okay? And we're going to check this out. So each brick is 24 centimeters. First of all, I'm going to convert that to meters. So I'm going to divide by 100, and I'm going to get 0,24 meters per brick. So that's the first thing. So that's per brick. Now we need our total of 19,49. We've got 19,49 meters, and we can divide that by 0,24 to get our answer of how many bricks he needs. But then I'm going to just check each of the sides to see if I've got enough bricks, because we might have to cut up bricks. So let's do that first. So 19,49 and divide that by 0,24 to see that he needs 81,2 bricks. So that's 81,2. But in actual fact, we have to round up in this case, so we're going to make it 82 bricks. But what I just want to check is how many bricks we need on each side. So I'm going to take each one of our calculations. So it was 6,2, and I'm going to do that calculation. And 6,4, and divide that. And 6,89, and divide that. Just to check that I actually have enough bricks. Because if we're cutting bricks on the one side, we might not be able to use that half for one of the others. So let's do this calculation quickly. 6,2 divided by 0,24. Will you remember our numbers for us? Then we're going to make that 26.
All right.
You remember our numbers. 26. Ta's going to remember our numbers. Then we're going to go back here and we're going to say 6,4. And we're going to get 27. Okay. And lastly, we're going to say 6,89 divided by 0,24. And we're going to get 29. So give me those numbers again.
30. I'm joking. 26. 26. 27.
27.
And 29.
And 29. Okay, now what happens if I add these three numbers up? Let's see, I've got 26 plus 27 plus 29, and I see here that I need 82. So in actual fact, both ways worked out that I need 82 bricks. So 82 was perfect, even though we worked with the halves and the cutting off worked perfectly. So, and our last question says, use your answer to question 2.2.2 to calculate the amount that the bricks will cost if each brick costs R4.43. So now how many bricks did we need? We needed 82 bricks, and we're going to times it by R4.43. I don't know what the price of bricks is, Ta, but this seems like quite a lot of money for bricks. R4.43. 82, but I suppose that's why I'm not building.
It depends on what type of brick you're also getting, probably.
Absolutely, I suppose so. 363 Rand 26. So we end up with 363 Rand 26, I think I said. Let's just double check that I've got that number correctly.
Yes.
36326. That's perfect. Don't forget that's Rand. And I think maybe at the end of this question, it's time to take another little break.
All right,
Yeah, so
we
I'll
should
see
do
you
that.
soon.
So, mindsetters, I'm scanning through the page. I'm liking what I'm seeing. Just want to say thanks to Vasa for posting, and I also want to thank who else is here? There's so many names. But anyway, guys, just keep posting. Let me know what you guys are thinking. And yes, all I'm saying is just keep talking to us on the page. Yes, Zalziwe. Just wanted to say, hey, what up? Thank you for posting. But anyway, we're gonna see you guys after this break. See you soon. And welcome back, Mindsetters. I hope you're ready. You're now back and you've got your notes out and you're going to continue making more notes because it's so super important that you're making notes right now because you need to remember the stuff. Yes, we're back. We're ready. We're going to continue with the rest of the show. And Haley's just going to take it away from me. Haley, take it away.
Thanks, Ty. Hi, guys. Okay, I think that we've done a little bit of measurement, and now let's move on to models. So we've got a warehouse manager has to pack boxes that measure 30 centimeters by 25 centimeters by 25 centimeters. The shelving is 3 meters long, 80 centimeters wide, and the height between the shelves is 1,05 meters. Now, at this point, I have read so many numbers that I'm really not sure what we are trying to do. So let's read the question, and then we're going to do it one step at a time. What would be the best way to pack the boxes on the shelves? So for me to do this, I always like to draw pictures. So first of all, let's look at his box. So the box that we're dealing with, okay, let's make our box in green. We've got a 3-dimensional box. And we've got some measurements. So we've got 30 centimeters, we've got 25 centimeters, and 25 centimeters. So I've got a length, a breadth, and a height. Now, doesn't say anything about the box needs to be a specific way. So I suppose I could actually turn the box around. So I'm just going to make this the length, the breadth, and the height. Okay. And I always like to label my diagrams. What I notice about this is it's in centimeters. So I'm actually going to make a note that this is all in centimeters, because then I remember reading things about meters. So our shelves are 3 meters long. So let's change our colors. We've got 3 meters long. They are 80 centimeters wide. Okay, that's not working. 80 centimeters wide. Okay, so that's the bottom of our shelves. And they are 1.5. How's that diagram? Does that look like a box? Not quite such a great box. Let's try that again. Okay.
Let's give that one more
try
shot.
that again. Right. I'm going to draw my box. Right. So I've got height and then a width. Let's try that. That should work.
There we go.
Okay, that looks a bit better. Okay, and what do I know? This is 3 meters. Now I'm going to convert this to centimeters. So I'm going to make 3 meters, and that's times by 100, so it's 300 centimeters, so that I remember I'm working in centimeters. And then, I don't know what that's doing there. And then I've got 80 centimeters wide, so I've got 80 centimeters, that's my width. And I've got 1,05 meters. I'm going to multiply by 100, and that's 105 centimeters going up. So now I need to pack these boxes into, the green boxes into there. And I could try this in a whole lot of different ways. So what I think I'm going to do is I'm going to take, this is going to be my length, that's going to be my breadth, and that's going to be my height. And I'm going to divide my length by length, my breadth by breadth, and my height by height to see how many boxes I can fit into each way. So let's try that. So what we're going to do is we're going to say, well, my shelf was 300 centimeters, and if I divide it by 30, then what do I see? I can fit 10 boxes. And this is assuming that we've got no space in between. I can fit 10 boxes along the shelf. Now, how many can I fit in the width? So now I've got 80, and I'm going to divide that by 25. And you know what? I'm going to get my calculator out. So I'm going to say, well, 80 divided by 25, and I get an answer of 3,2. I can't have comma 2s. I can't have half a box or a quarter of a box or 0.2 of a box. So I'm going to round that to 3. So in my width, I'm going to have 3. So that was 3. So 3 wide. So this is long, this is our length, this is our width, And going up, how many can I pack going up? And somehow I need a little bit more space. So let's do this at the bottom here. We had 105 centimeters divided by 25. Get our calculator out again. So I had 105 divided by 25. And in this case, I get 4,2. So I can fit 4. So the way I'm going to pack them, and this is what I need to now explain, is a best way to pack the boxes. And this is one way of packing the boxes, and I think it possibly is the best way. So I'm going to put, on the length, I'm going to put 10 boxes, and in the width, I'm going to put 3 boxes, and the height, I'm going to pack 4 boxes high. So that's how many boxes. 10 across. And I could actually draw a picture of it. So I could say, well, okay, I've got 10 going here, and okay, I'll draw this long picture. But I think explaining it like that would actually explain it as well. So what does our question then say? What would be the best way to pack the boxes? Guys, there's probably other ways of packing the boxes. Like I say, we could have turned the box and we could have said, well, okay, instead of making our 30 centimeters on our width, maybe we could have made our 30 centimeters on our height. And we could have manipulated the numbers and maybe we would have got more boxes in. But this is one way. And how many boxes can you put on the shelf using your arrangement? Okay, so my arrangement, I had 30 boxes. Let's just change our color so we don't get confused. I didn't have 30. I had 10 boxes. Okay, try that again. I had 10 boxes across the width. I had 3 across the width and 4 across the height. So all I need to do is multiply those. I'm going to use my calculator. 10 times 3 times 4. And I see that I can fit 120 boxes. 120 boxes. And what's nice about the second part of this question is it really is based on your calculations. So if you had put your boxes in a different arrangement, and maybe you got more than that or less than that, it's still based on your calculations. So whenever we're dealing with boxes, again, it's just kind of clearly like your length times breadth times height. So it's just a volume formula with boxes. Okay, have we answered all the questions there? I think we have, so let's move on. Right, now we're doing tables and equations. So according to the World Health Organization, obesity is rising throughout the world. Obesity is a disorder that occurs when the body intakes exceeds energy expenditure over a long period. It is assessed according to the body mass index, or the BMI, which is calculated by dividing the weight in kilograms by the height in meters squared. And that is your formula. Now, before I carry on with this question, because I always have this discussion with my kids in class, if you're calculating your BMI, and you get a number that seems rather strange, please don't worry about it. Please don't stress, because there are more things to obesity than just the BMI number. So it's important. You've got your bone, how heavy your bones are and how big boned you are. So just rather, if you do think there's a problem, then I don't know, can I tell them go see a doctor or talk to your parents? It's like,
that would be the best. If you are concerned, the numbers really out there, you're like, okay, maybe I might just want to go get my blood pressure checked and everything. Just make sure you're good.
I always find it a problem, if I just throw out this BMI and then think, oh, I can do mine. And I know mine's kind of scary, so I don't do my BMI anymore. Okay, but they've given us the formula. It's your weight in kilograms divided by your height in meters squared. And people are classified in the following ways. So you've got underweight, you've got normal, overweight, and obese. And then they give you the BMI that should be. So if you are less than 18.5, you are underweight, between 18.5 and 24.9, normal, overweight from 25 to 29.9, and over 29.9, you are classified as obese. A learner has a height of 1,73 meters and a weight of 73.5 kilograms. Calculate his BMI and give his weight classification. So we have our formula. Our formula, they told us, was your BMI, and again, I'm going to rewrite this formula, was your weight in kilograms, so I'm going to just write it as kilograms, divided by the height squared. So his weight in kilograms was 73.5 kilograms divided by the height, 1,73 squared. And if you're not using a scientific calculator, remember you can times that twice. So we've got a scientific calculator for today, so we're going to use it. In fact, I'm going to use my fraction button now. 73,5 divided by 1,73 squared. That's watch what you enter on your calculator. 73,5 divided by 1,73 squared. And we get an answer of 24.558. I'm going to round that off to 24.6. Or 24.56. So 5.6. Now, what would be the units here? They haven't given us the units, but our units we can see would be kilograms per meter squared. So it's important that you add your units. So we have done kilograms per meter squared, so 24.56. We've calculated his BMI. Now we need to give his weight classification. So 24.56 fits into, it is less than 25, less than 24.9. So he fits into that category, therefore is normal. So this is totally normal. Right, and I think we've answered the question. We've got his weight calculation, and everything's done. I think we've got time to do one more quick question. Dom and Alice do a survey of 6-year-olds in the local primary school to ask whether or not they could swim. The results are summarized as follows. So whenever you've got a table, I like to understand the table perfectly before I carry on with the question. So we've got 6-year-old swimming survey. We've got the number here of swimmers, clearly. These can swim. We've got boys and girls, and cannot swim boys and girls. So, how many children in total were questioned? They've given us the totals of each one of these. So in actual fact, if they want to know how many children in total were questioned, we just need to add those numbers up. So let's get our calculator out, and we can quickly add these. It's 350 plus 228 plus 778 plus 432. And we see that they 1788, so 1788 children. So that's how many were surveyed. Calculate the percentage of boys who can swim of the total number of children surveyed. So whenever they ask us for the percentage, we times by 100. We want the percentage of boys who can swim out of the total number. So there's our total number. And how many boys can swim? Well, we've got our swimmers, and we can see that it's 350. So we've got 350 boys that can swim, times it by 100 gives us our percentage. So I think I'm trying to rush through this. So 350. I think I'm going to have time to just finish the sum. What do you say, Ty? 350 divided by 1788 and times by 100, the percentage is 19.57%. 19.57%. So if we answered the question, we've got the percentage of boys who can swim out of the total number of boys. And I think at this point I should probably end off because I'm running out of time and I want to get to the next question and I want to try and help you. But guys, I think we've got revision again next week. I'm sure that we do. So I'm going to end off here. Hopefully we'll pick up here next week. So I'm going to hand over to Ty. I'm going to say goodbye and just work hard, practice lots.
All right, mindsetters, you heard from Haley yourself. You guys need to make sure you tune in. Yes, especially since next week we're going to be starting spring school, so make sure you get on the page, get chatting to us, talk to us. Let us know what particular areas, if you have areas that you're I need help here. If I don't help here, exam for me, it's over. But that's what I'm saying. You guys need to talk to us. Let us know what you guys are wanting us to cover specifically. Just put it up on the page. Just write hashtag spring school subject. and let us know what you guys want us to cover. And then we'll get on that, and we'll make sure we look them up, and then we'll make sure that we get back to you guys with those lessons. But then make sure you also talk to your friends, because we're trying to get those numbers up. We're trying to get 20,000. You know, we might have a little party, take off my hat. You know, you never know what's going to happen. But anyway, Mindsetters, it's been fun. Make sure you talk to each other. But for me, this is where I sign off and say, see you next time.